In this video, we're going to learn everything about India's lunar mission, Chandrayaan-3. As you can see from the name Chandrayaan-3, the number 3 indicates that it is the third lunar exploration mission by the Indian Space Research Organization, ISRO. Chandrayaan-3 is the name of the spacecraft. It was launched on July 14, 2023 at 2:35 p.m. afternoon Indian Standard Time from the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh, India. The entire spacecraft consists of 3 parts, a lander, a rover and a propulsion module. And this entire spacecraft is loaded onto a launch vehicle. The name of the launch vehicle is LVM-3. It is a 3-stage medium-lift launch vehicle developed by ISRO. It is designed to launch communication satellites and spacecraft into geostationary orbit. Now don't get confused between a launch vehicle and a propulsion module. The purpose of a launch vehicle is to carry a spacecraft into orbit. After that, the launch vehicle is no longer needed. Once the launch vehicle has done its job, it will either burn out or fall into the sea. Once the spacecraft Chandrayaan-3 is placed into the Earth's orbit, it will start circling the Earth's elliptical orbit on its own, just like any regular satellite. If you read about Kepler's laws of planetary motion, you will understand everything. Here are the 3 laws. This explains everything about planetary motion. Now what happens is that, as you know, Moon revolves around the Earth. If you look at Earth's elliptical orbit, you will see that at some point the Moon's orbit is very close to the Earth, and then there is a farthest point from Earth. When the Moon's orbit is closest to the Earth, it is called perigee, and when the Moon is far away from the Earth, it is called apogee. So when the launch vehicle will put the spacecraft into Earth's orbit, as I said, this spacecraft will start circling the Earth's elliptical orbit on its own, just like any regular satellite. Now what the scientists and engineers sitting in the Satish Dhawan Space Center will do is, the moment the spacecraft reaches the farthest point, that is apogee, they will start the propulsion module, which will slightly push the spacecraft sideways so that it enters into the second loop or Earth's second orbital ring. The reason this push is done at the farthest point is because the velocity of any satellite or any spacecraft in the orbit is higher when it is near the planet, and it slows down when it moves away. Once again, the engineers and scientists will start the propulsion module and slightly push the spacecraft sideways when the spacecraft reaches the farthest point, so that the spacecraft moves into the third loop. On completing 5 such loops, the spacecraft will finally fall out of Earth's orbit and move into the Moon's orbit. In other words, the spacecraft will break free from Earth's gravitational pull. This point or position is called the Lagrange point. It is a point where the gravitational pull of 2 large masses is precisely equal. Now once this spacecraft enters the Moon's orbit, the reverse will happen. One loop after another, the Chandrayaan-3 spacecraft will get closer to the Moon. When it is 100 kilometers away from the Moon's surface, the lander Vikram will detach itself from the propulsion module and begin its descent onto the Moon. It will do a soft landing. Now the question is, what happens to the propulsion module? As I said, about 100 kilometers away from the Moon's surface, the lander will detach from the propulsion module to continue doing soft landing. The propulsion module will keep circling the Moon's orbit as a relay satellite. It is equipped with a communication system which allows it to relay signals between the lander, rover and Earth. In the case of Chandrayaan-3, the propulsion module will act as a communication relay satellite after the lander and rover has soft landed on the Moon. The propulsion module is equipped with a low as well as high gain antenna. The high gain antenna will allow the propulsion module to communicate with Earth even when the lander and rover are in the shadow of the Moon. A low gain antenna will allow the propulsion module to communicate with the lander and rover. Once the lander detaches from the propulsion module, in the next step, it has to do a soft landing. It cannot go hard and bang on the surface of the Moon. So to do a soft landing, this lander has 4 thrusters, or you can call them engines, which will provide an upward thrust, and the exhaust nozzle acts like a gimbal so that it slowly descends and lands softly. All the calculations have been done during trials on Earth. The most important thing here is to understand that the lander will soft land on the lunar surface near the South Pole region. Now, an important question that may come to your mind is it necessary to do a soft landing on the Moon? Why can't we use a parachute? We have seen the United States using parachutes for dropping Curiosity and Perseverance rovers on Mars. So, don't you think using a parachute would be simple and cheaper than using engines to slow down the descent? So, this is where you have to understand that Mars has an atmosphere while the Moon doesn't. The gravitational field is weak on the surface of the Moon. It is not strong enough to hold the atmosphere on its surface from going back to space. You need some air to be put under the parachute, which will create some drag. That's how you will land slowly. The planet Mars has some air, but the Moon has none. That is why in a lunar mission, parachute will not work. You need thrusters. Now, once the lander Vikram has done its soft landing on the Moon's surface, the doors under the lander will open and rail tracks will slip out. A rover called PRAGYAN will slide down the rails onto the Moon's surface. The rover has wheels to move around the Moon's surface, and both the rover as well as the lander will get to work after soft landing. It will pick up soil and conduct experiments. Furthermore, it will also drill in the Moon's surface to measure its thermal conductivity. So overall, the purpose of the rover and the lander is to explore the lunar surface for signs of water and simultaneously study the lunar geology and environment. Now, I want you to understand that there are three important things right here. The first is the propulsion module that is circling the Moon as a relay satellite. It weighs around 2148 kg. The second thing is the lander Vikram, which is going to be stationary. It will sit in one place and it is not going to move. The weight of the lander is around 1725 kg. And the third thing is the rover PRAGYAN, which is going to move around for collecting samples, conducting experiments, taking pictures. It is also going to map the lunar surface. And finally, it will also do some drilling. The overall weight of this rover is around 27 kg. The rover has 6 wheels and is powered by solar energy. It carries 2 spectrometers to study the composition of the Moon's surface. This rover will move around the landing area for about 14 Earth days, which is roughly equal to 1 lunar day of sunlight. That is also the total time taken by the Moon to make one orbit around the Earth. The Vikram lander is equipped with 4 scientific instruments. The first one is seismometer, which is designed to detect any moonquakes. I'm not saying earthquakes, it is moonquakes. The second instrument is to study how heat moves through the lunar surface. The third instrument is to study and understand the plasma environment around the Moon. And the fourth instrument is the retroreflector, which helps to understand the gravitational interaction between the Moon and the Earth. Now all these instruments, both from the lander as well as the rover, will collect data in digitized format, and it will transmit data in the form of electromagnetic waves to a receiver on the propulsion module, which is circulating the Moon. The propulsion module will further transmit the data back to Earth. And by the way, the Chandrayaan-2, India's previous lunar mission, which was launched in July 2019, that is still orbiting the Moon. Even that mission had a rover and a lander, but they couldn't make a soft landing and they crashed during touchdown. Currently, the only component of Chandrayaan-2 that remains in lunar orbit is the propulsion module, and it is still active. In the event of an emergency, it has been suggested that the propulsion module of Chandrayaan-2 will be used as a backup receiver for the Chandrayaan-3 mission. And always remember, signals through space are sent in the form of electromagnetic waves like radio waves, microwaves, infrared waves, etc. They don't need a medium to travel from one place to another. Now these three things, that is the propulsion module, the lander and the rover, they all will be up there on the Moon forever. They are not going to return to Earth unless someday an astronaut lands on the Moon and decides to bring them back as mementos. Another interesting fact is that the rear wheels of the PRAGYAN rover have been carved with the ISRO logo and the national emblem. This symbolic gesture will mark India's presence on the Moon's surface. It will act as a reminder of India's growing space program and its commitment to exploring the universe. The entire mission budget of Chandrayaan-3 costs roughly around 615 crore rupees. The mission was launched on July 14th at 2:35 p.m. The lander and the rover are expected to land near the Moon's South Pole region on 23rd August 2023. I will keep providing you with the information about the future progress of the mission as it continues. As of now, this is everything you have to know about the Chandrayaan-3 lunar exploration mission. I hope you found this video informative. Thank you for watching it.